we did one problem on Friday using this formula, summing up an not infinite, a finite geometric series based upon the partial sum. And I did change the formula slightly. This is the way the book has it. I prefer writing it like you see on the right here. They're the same thing, so it doesn't matter. And then there is this other version down here that I generally don't use. If you wrote it down, if you want to memorize it, you can use it. But here's the deal, I want you to understand. On the test, we're going to give you most of the formulas. I need to double check, frankly, whether there are recursive formulas on there, but certainly the nth term formula and the sum formulas that you have on your note sheet there, they'll be on the test. Of course, it won't be identified. You have to be able to choose which one. You have to know, okay, this one's the arithmetic sum formula, this one's the nth term for an geometric series and so forth. But the formulas themselves will be there. These that I have on the board, you won't need those. Okay? You could actually, if you're summing up an arithmetic, you could use these formulas here, but you don't need it because you can just use the arithmetic. So they won't be on the test because you won't need them. Right? But this is an alternative, frankly. All right. We did that one. Let's see. Yeah, write this one down. So you can keep copying. I just want to talk about the powers of 2 for a little bit. You should know that this is to the power of 10, yes? Then this is to the power of 11, to the power of 12, to the power of 13. So to the power of 13 is to the power of 3 times to the power of 10. Or it's 8 times that is to the power of 13. So I'm saying, to the power of 13 it'll look like 8,000. It's roughly 8,000. On the computer, we call a kilobyte because it's that many. It's not actually 1,000. And a megabyte is called a megabyte because it's this squared, which is not a million, but it's close to a million. And a gigabyte is that number cubed. And a terabyte is the number to the power of 4 and so forth. And so they're called kilobyte, megabyte, and so forth because they're close to those powers of 10. And so, but the computer thinks in binary, which is base 2, which is powers of 2. Anyway, let's proceed. Before we start this problem, I want you to realize, like here, it had to tell you that you're dealing with a geometric. Although if it says r equals 2, you're supposed to assume you're dealing with a geometric. I need to emphasize this, though. Look at this. On these problems, we did this one, and it very nicely said it's geometric series, but it doesn't have to. On the test, it won't. And so before you start, you decide what you're dealing with. And clearly, you're not adding the same thing every time, so it's clearly not arithmetic. But before you treat it like geometry, you should, confirm. In other words, if you do the second over the first, you get negative 3/2. And if you do the third over the second, well, that also equals negative 3/2. So it is indeed geometric. So I'm saying, when you get to the test, you have to choose the right formulas, and the first step in that process is making sure you know what you're dealing with. If it's geometric and you want to find the sum, well, then you're using the geometric sum formula. All right, so this one, let me write down the formula first. If you want to sum up part of a geometric series, then this is your formula to use. Let's plug in what we know. We know the first term is negative 4. Actually, let me pause for a second. The thing I recommend is just to make sure you have a good feel for how the sequence itself is working, is write it out. In other words, they didn't give the sequence, they just gave you some information. But if you start with negative 4 and you're doubling every time, then this is your sequence, yes? And eventually you'll get to that last term they gave you. Okay? I'm just saying, that's what we're dealing with. Come back here. We know r is 2, so put a 2 there. And it's 1 minus 2 in the denominator. The problem is we don't know n. So you need to pause here and start use the nth term formula, which goes like this. Use this, see if I can write. It's first term times r to the power of n minus 1. We could use that on Friday. Once again, you're starting with the first term, and you're multiplying by r repeatedly, n minus 1 times, actually, to get to the nth term. And the point is, we need to know what the term number is for that last term, so put the last term there, and then the next first term times r. Now, One thing I want you to appreciate is that, like here, you could divide 8192 by 4. It's not that hard. But you could also know, if you happen to know that this is to the power of 13 I mean, it's actually the opposite of that. If you rewrite it as a power form, that's going to rewrite the -4 as a power form. You get to work with exponents instead. By the way, just for the record, that negative sign, it's just going to cancel out, isn't it? You're going to divide by negative. In other words, here, what I wrote is not -2 to the power. It's not. It's the opposite of 2 to the power of 13, the opposite of 2 to the power of 2. At any time, you can really just cancel negative. Here, I'm going to stick with the way I've been doing it in the previous periods. I was trying to show you how you could do the division, but just with power forms instead of the numbers. So instead of divide by -4, divide by the opposite of 2 to the power of 2, and you get a positive 2 to the power of 11. Which actually is very nice because it's an exponential, so eventually you want to have an exponential on both sides anyway, and we already have that. And so it turns out n is going to be 12. Now, the whole point was to find out the fact that this number apparently is the 12th term, so n is 12 in our sum formula. We're trying to find the sum of the first 12 terms. So let's see, 81 12th term. Yeah, so this becomes 1 minus 4096. Minus -4. The denominator is -1 because 1 minus 2 is -1. That cancels, making it a positive. So all you need to do is figure out what 4 times but anyway, figure out that product and you'll have it. Turns out to be negative. Right. And what is it? Is that right? Now we're done. So that's a really weird picture of it. See if I can fix it without destroying everything else. Yeah, that looks better. By the way, I feel compelled to mention one little thing we could have done differently. Right here, first of all, like I said, that is not -2 to the power. It's really -1 times 2 to the power 2, or the opposite of 2 to the power 2. All I'm saying is, you could have actually just combined these, couldn't you? Like, actually drop the negative sign here on both sides, because it's going to cancel anyway. When you combine these, so if that's gone, actually, then that's just 2 to the power of n plus 1, because n minus 1 plus 2 is n plus 1. So from right here, you could have done that, and then the exponent set equal tells you n equals 12. Actually, a little nicer way to do it. Once you got them all to be power forms, you didn't have to think of division. You could have just combined these. Anyway, questions about that one? One thing I need to emphasize is that I would say pretty much every time, or most of the time at least, when you're trying to find the sum, and I don't care whether it's arithmetic or geometric series, most of the time you do not have enough information to finish the formula. So you're going to have to set up the nth term formula and use it to find the missing information. Okay, that happens, well, it's just about every time. So you just expect that. All right, write this one down, except for one thing. We're going to simplify it before you write it down. In other words, look, these are both -2 to the power. What do you get? What do I get when I add the exponents? So just write it that way. So now write the problem. Now, these can be confusing just because the summation is going from n equals 3 to 8. What I'm going to do is just write out the sequence that this would generate, and then just sum up the sequence and forget about the summation that generated it. If we start with 3, what's negative 2 to the power of 3? Negative 8. And when you plug in 4, because you do that next after 3, you get positive 16. And then 5 gives you negative 32, and so forth. And then you plug in 8, negative 2 to the power of 8. Even, so it's positive, positive. 200 something. Yes, 256. Okay, so we're trying to sum up that series. It's geometric, by the way, obviously because you're multiplying the negative 2 every time. So let's use that same formula. A goes for the first term goes there. Then 1 minus r, which I just said is negative 2, to the power of n, which once again I don't know. And then the denominator, by the way, would be 1 minus r, which is 1 minus negative 2. Now, how many terms is this? Well, it came from this. How many terms would this produce? Not 5, but 6. And by the way, there weren't that many terms. You could have just written them out, just so you can see. It would be 64, then negative 128, and then positive 256, which is indeed the 6th term, right? So you do 8 minus 3 is 5, plus 1 is 6 terms. Okay? So this is a 6 in a formula. Just like I said, be careful that you get that right. If you mess that up, then you're obviously getting the wrong answer. You're plugging the wrong numbers into your formula. All right, let's figure this out. 2 to the power of 6 is what? Thank you. You guys are scaring me. I know it's Monday morning, but come on now. And then the denominator is 3, yes? So really, and then this is really just negative 63. So here, I'm going to rewrite it one more time. That's negative 63. And 3 goes in 63 21 times. So that's all you need to do is 8 times 21. So negative times negative, so it's positive. Positive what? 168. And we're done. Let me say again, on the test, even if you can write out all the terms, you're supposed to find this answer by using these formulas, not by adding up the terms you wrote down. That being said, if you look at what we wrote down, it seems like every positive term was like bigger than the negative term before, right? And so you can see, these 2 add up to a positive, then these 4 add up to a positive, these 6 add up to a positive. Yeah. So look at your sequence, make sure your sum makes sense. But like I said, you're supposed to be using these formulas to find the sum. All right. Now the other formula, the last formula, we'll get to in a second. The idea is we're going to take it in a geometric series and after the whole thing, the whole infinite series, okay? So just watch. I'm trying to take the same formula we just used and see what happens to this formula as then just goes to infinity. The thing is, there's 2 different cases. And what I mean is, like it says here, if r is greater than 1, so like let's say r is 2, for instance. And if r is 3, 4, anything greater than 2, it'll behave like this. Well, as n gets bigger, to the power 2, to the power 3, to the power 10, to the power 20. To the power 10, I told you is around 1,000. To the power 20 is around 1,000,000. To the power 30 is around 1,000,000,000. So I'm up to n equal 30. I'm already up to that part being 1,000,000,000. And so this whole thing is going to blow up. Okay? It's going to diverge to infinity. We can't do that. It does not give you an answer. But think about what happens if you plug in something like a half instead. So if r is, let's say, a half, then this part here is going to be a half, and a fourth, and a third, and a half, a fourth, and 8, which is 2 to the power 3, a 16th, a 32nd. That part's tending towards 0, yes? As this part tends towards 0, what does that whole part of the formula do? It approaches what? 1. Think about this. When I'm subtracting, when we're talking about as n goes to infinity, then I'm subtracting a half, then a fourth, then an eighth, then a 16th. So my sum, 1 minus a half is a half, 1 minus a fourth is 3/4, 1 minus an eighth is 7/8, and then it's 15/16, and then 31 over 32, 63 out of 64. Keep going, eventually you get to 1,023 out of 1,024. You can't talk today. Which is almost 1, and then it gets closer and closer. So as n goes to infinity, this part tends towards 1, so you ignore it. You just get rid of it. Because multiplying by 1 doesn't do anything, right? And you get, not that, but that. Write this down. On the green sheet, bottom right corner, there's your formula for summing up a whole infinite geometric series. Okay? Correct. Bottom right box. And make sure you put the condition down there. This formula will not work on any arithmetic sequence. The sums always diverge to infinity. And it won't work if r is 2, 3, 5 halves, 3 halves. Those are all numbers, r values that are greater than 2, or greater than 1. It won't work. R has to be less than 1 for this to work. All right. I'm not going to do this one, have you write this one down, but just watch. If I try to apply this formula, so I'm trying to sum up in a whole infinite geometric series, you do the first term divided by 1 minus r. First term is a half. And what are you doing every time? You're taking half of, so r is actually also a half. Well, you get a half over a half, which is 1. Which is what I told you would happen if you summed up that series. Okay? Look, this isn't the point. If you have a series where the terms are approaching 0, so they're converging on 0, then the sum is going to be approaching some number. It's asymptotically approaching some number. We say that the series is converging on that sum. Okay? So, here, write this down. Notice in the directions I scratched out the part which told you what kind of series it is. Because you're supposed to figure it out. If you look at those numbers, how would you get, let's think in terms of arithmetic sequences, how would you get from 1 to a third? You would subtract a third, yes? But then if you subtract another, no, you subtract 2/3. Sorry. I can't talk today. If you subtract 2/3, it works here, but then clearly it does not work there. It's not arithmetic. It's geometric, and r is what? A third. You're multiplying by a third. You're taking a third of it every time, yes? And so our formula that I showed you does apply because, once again, it's geometric and r is less than 1. So let's figure it out. The first term over 1 minus r, so that's 1 over 1 minus the third, which is 1 over 2/3, which is 3 halves, or 1 1/2. We're done. Much easier. Much easier. Now, I want to show you, that this really does work. Or let's watch. Another way to look at it is, if I start finding the only to get 1, that's kind of boring. Some of the first 2, though, you get 1 1/3, which is not quite at 1 1/2, but it's getting there. If you want to sum of the first 3, and you need to add a ninth on to 1 1/3. A third is 3/9. So if you add a ninth on this, you get 1 4/9, which is pretty close to 1 1/2, isn't it? Yes? If you add on a 27th, because that'd be the next term, then how many 27ths is this? 1 and 12 27ths, yes. So the fourth sum will be 1, and this is, we said 12 27ths, 1 plus 1 more, 13 27ths. Which is even closer to 1 1/2. And then I'll just tell you the fifth term would be 1 and 40 out of 81, which is closer to 1 1/2, and then it just keeps getting closer and closer forever. It's 243 next, and it'll be 121. And so the sum is converging on 1 1/2. Okay? So think about this, by the way. If I ask you to find the sixth partial sum, you use that other formula and find that ugly answer. say find the sum of the whole infinite series, you get this nicer formula with a nicer answer. So, all right, write this down. And write down the directions as well as the problem. 10. Right. 4 tenths times a tenth is 4 hundredths, times a tenth is 4 thousandths, times a tenth is 4 10,000ths, and so forth. So it is an infinite geometric series where r is less than 1, so let's use our formula. The first term is the 0.4 over 1 minus r, and 1 minus a tenth is 9 tenths. But multiply top and bottom by 10, you get 4 ninths, don't you? There you go. Turns out it's 4 ninths. A little bit of resistance. Turns out 0.1 repeating equals 1 ninth. So 0.5 repeating is 5 ninths, 0.7 repeating is 7 ninths, and so forth, all right? But this proves it. Now, let's take that and apply it to kind of a special case. And write that down. I mean, write down everything. Except I think we will go and stick with decimals. In other words, if you want to write this down the same way as the last one is, 0.9, 0.09, 0.009. Same as the last one, except for, same result, but it's kind of. It's just to most people more surprising. In other words, we're going to find the sum of this whole infinite series. The first term is 9 tenths, and r is a tenth again, right? You can write it as a fraction if you want, but I'll use it as decimal. So the denominator is 1 minus a tenth, which means you get 0.9 over 0.9, which is the same as 9 over 9, isn't it? Multiply by 10 top and bottom. But 9 ninths equals 1. And that's the weird part. So it turns out 0.9 repeating equals 1. And when I say equals, I don't mean approximately, I don't mean it's close to 1, I mean it equals 1. There's no difference between that number and 1. That's the surprising part for most people. And, yeah. No. Well, yeah, 0.3 repeating is precisely a third of 1, yes. There you go. And 0.3 repeating is equal to 3 ninths, which does equal a third, yes. Think of this, by the way. If I took the dot off, I'd have not quite 1. It'd be 1,000th away. Okay? That's 999 thousandths, so it's not 1. If I put 6 nines there, then I'd be a millionth away from 1 still. Not equal to 1. I go out 9, I'd be a billionth away from 1, okay? And so if you ever stop short, then it does not equal 1. You're short of 1. But if you add up the whole infinite series, it does equal 1. There's no difference, absolutely no difference between it and 1. Okay? You subtract the numbers, you get 0, exactly 0. Kind of weird, I think. All right, we're going to take it up a notch. So there are 2 digits repeating. It's very similar, but not quite the same. Here. And just write, write the directions. So the first term is obviously that. What is r this time? It's 100th. Not a tenth, but 100th this time, right? So that's the only real difference. And then our answer is going to look a little different, though. So the first term goes there. 1 minus r goes there. But 1 minus 100th is 99 hundredths, 0.99. What if you multiply top and bottom by 100, you get 37 out of 99. Which can't be simplified, so I'm saying if you have 2 digits to repeat, you can always write it as that over 99. We will stop there.